So good morning to all of you. So class 8 students, you please pay attention. Today my main focus to talk to you is regarding drawing of histogram. Drawing of histogram, as in yesterday's lecture, I have uploaded the information about your data handling syllabus, whatever is a part of your topic. So if you go through your first exercise there, exercise 5.1 is totally related to histogram, and in first 2 or 3 questions he is asking to draw the histogram. So some important terms related to that I will be sharing with you, so that by tomorrow I can upload the solution of all the 6 questions. Today you need to do the practice of all those 5 to 6 questions, whatever are the part of your that exercise 5.1. In that exercise you are asked to draw the frequency distribution table. All the terms I have cleared to you in yesterday's lecture, and then please you try to draw whatever already you have finished up to class 7. I hope all of you know how to draw the bar graph. Especially in one question it is there, you draw the bar graph, so you know that. Otherwise tomorrow I will be giving you the solution, but bar graph is very important. I definitely will start with the bar graph first, because in yesterday's lecture I made that clear. Histogram is nothing but is simply the modification of bar graph. So that much will be the part of my discussion for today's lecture, so that before starting the exercise 5.1 we just can understand how to go for the drawing of histogram. And most important part you need to pay attention over there is use of graph and how to write the scale calibration. Please make a note of that. Scale calibration is very important. If you are going to commit mistake over there, then everything will be zero. So most of the students committing mistakes during that part. So few terms related to that, drawing the graph, I will be sharing with you through this lecture. But before that, I would like to share your syllabus for your midterm examination. So how many chapters, what are the chapters, you can make a note of that. So here are the chapter numbers and the name of the chapter. Please make a note of that. Chapter number and chapter's name. For your syllabus for midterm June 2021. So your chapter number 1 will be there, that is your rational numbers. Already you have done. Then chapter number 2, linear equations in one variable. Linear equations in one variable. This is there. Then chapter number 5, now we are going to start data handling. This will be another chapter. Then after 5, chapter number 6 will be there. Square and square roots. Square and square roots. Already we have finished. Then 7th chapter will also be there. That is your cube and cube roots. Cube and cube roots. Already done. And one more will be there. That is your 12th chapter. Exponents and powers. Exponents and powers. So as for the present situation, 1, 2, 3, 4, 5, 6 topics will be the part of your syllabus for your this midterm examination. So already you have finished 1, 2, then your square root is also over, 7th. Now this chapter we are going to start. So from the future coming examination point of view, we will definitely be sharing if any deletion is going to take place. We will let you know. Earlier it was decided that in midterm the algebraic expressions will also be added, but now I have discussed with other co-teachers that will not be the part of your midterm examination, that we will be taking in our post-mid examination. And the blueprint for your midterm examination will be uploaded very soon, maybe within a day or two. So you please wait for that and be clear with these topics. Start doing the revision of at least those chapters what already you have finished. So that's all about your syllabus and topics, lesson numbers. Please make a note of that. So now, how to draw the histogram? What are the important things we need to take care of? First of all, I would like to share about the bar graph. You are very clear with the bar graph. In bar graph, what we do? No, suppose you are talking about any case, there are families in which, in some of the families, one children is there, one children is there, two are there, three are there, four are there, and five are there. Suppose there are 6 families in which one child is there. There are 4 families in which 2 children are there. There are 3 families in which 3 children are there. There is one family where are the 4 children, and one family where there are 5 children. So, number of children, and these are the number of families. Now I want to draw the bar graph for this. So if I want to draw the bar graph, simply I will mark this 2, 3, 4, 5 is the frequency here. So I write 1, 2, 3, 4 and 5. So one children I am finding in 6 families. So number of families here I have written, and number of children, these are the number of families. Number of families. And here the number of children along x-axis. Number of children. So you are free to do that. There are like 6 children in one family, 4 children in 2 families, 3 children in 3 families, and 1 children in 4 families, and 1 children in 5 families. So 1 children in 6 families. So first bar I will be taking off this one. You can start from anywhere there. So this will give you the frequency. So 1 children is there. So there are how many families? 6 families. This is the first bar. This bar is taking 1 children only. So here it is 0. Then where it is, whether it is 5, whether it is 10, whether it is 20, that is up to you. You have to calibrate the scale accordingly. But you need to put a gap between this y-axis and the first bar. Then the rule you are following to draw the another bars is whatever the difference you will be taking between the first bar and the second bar. Suppose I am leaving 5 small boxes in between. So 2 children are there in 4 families. So I will proceed up to 4. So here I will block. The size I will keep remain same. So these are the 2 children. So up to 4 only. Up to 4 only I have to move. Then 3 children are there. So I will go up to 3 only. And I will keep the gap same. That is of 5 means 5. So here I will put 3 children only. So these are the 3 children in 3 families. Then 4 and 5 children. So 4 in one family. So 4 children I keep up to 1 only. So this is there. So this is there. So 1 children in 4 families. And again 4 children in 1 family and 5 children also again in 1 family. So that I can keep there. So this is the bar graph for this information I have drawn. One family 6 children, two families 4 children, three families 3 children, one family 4 children, and one family 5 children. So number of children I have kept over here, and the number of families I have kept along this axis, that is the y-axis. Horizontal is always the x, and vertical is always the y. So this is the bar graph. The main rule to draw the bar graph is we are free to leave this distance between this line of y-axis and the first bar. How much distance, that is up to you. But when you are putting the gap between the first and the second, that you need to keep same throughout between the other bars. So this is the way in which you have drawn the bar graphs in your previous classes. Now when we have to go for the histogram, and here we did not to take care of 0, 10, 20, 30, 40, no. But when we are talking from the histogram point of view, histogram we says is the modification of bar graph. Histogram. First of all, you just make it very clear what is the difference between the bar graph and the histogram. These are the bar graphs you have done. I am just sharing the example with you. But if you are talking about the histogram is something like this. Means what is the difference between the two you are finding there? There is a gap between these rectangles. You can see these bars. So when these are kept together, adjoining to each other, now there is no gap between these rectangles, these bars. So you are kept together, then such a graph is called histogram. So this is histogram. Y-axis, x-axis, this is the origin. This is the bar graph. This is the bar graph. So again, y-axis, origin, and here it is the x-axis. So when these bars are kept together, even with the y-axis, so that depends. All the time that is not going to happen. You can start it by putting a gap, but after that, once you have started with the first bar, then second, third, fourth will all be joined together. No gap will be there between those bars. So that's why we says histogram is the modification of bar graph, and these are taken together by keeping no gap between the bars is called a histogram. Now from the scale calibration point of view, again the frequency will be there. Frequency will be there along this axis, and class intervals, here we see the class intervals along the y-axis. So here when you are just preparing your frequency distribution, there you need to write the data in groups, and that data will be kept in such a way that 0 if it is 10, next will be 20, next will be 30, next will be 40, next will be 50 in continuity, no gap will be there. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50, and so on. Now suppose from this histogram point of view, I am talking about some, like here I put this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and then so on, 7, 8. Now I am talking about the test score. Test score marks scored by the students in a class of 50 students out of 10. Out of 10, so 0 to 10 students. 50 students are there. I have made a group of 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So these are the marks. These are the marks, and these are the number of students. Here, these are the number of students. So a test of 50 marks was conducted in a class, and draw the data by histogram. They represent the data by histogram to show the marks scored by the students. So there are 3 students who scored the marks between 0 to 10. Then there are, I'm taking here 2 students who scored the marks between 10 and 20. Then there are 6 students who scored the marks between 20 and 30. Then there are 8 students who scored the marks between 30 and 40. And there are again 2 students who scored the marks between 40 and 50. So these are the marks I have written over there, and these are the number of students. So number of students is frequency. Frequency always we will be taking along y-axis, and number of students we will be dividing in small groups, and these groups are called the class intervals. These groups are called the class intervals. So there is no gap. I'll come to some other important facts about drawing the histogram, you can say. So I have started with 0. So there is no gap between 0 and 10. That's why I have joined this with y-axis. Please make a note of that. So 0 to 10, then it will be worked out. No gap will be there. Next will be 10 to 20, 20 to 30, 30 to 40, 40 to 50. So here I am drawing the rectangle. Size will same. This is, please make it this size, this size, this size, this size. Everywhere will remain same. You just cannot squeeze. That cannot be increased or decreased. Once the scale is calibrated, means 1 centimeter. So all the rectangles will be consisting of the same width, that is equal to 1 centimeter. Please make a note of that. So then 10. So you will move up on this reading of 10 up to 3 and join it here. Then again your next score is 2, 10 to 20. So at 20 you move up to 2 and join it with this. Then 20 to 30, at 20 you have to go up to 6, and on 30 you can block that. Then 30 to 40 there is 8, again you can proceed on 30 up to 8 and block that on 40. Last automatically will be getting blocked at 50, and the score for that is 2. So you just cannot go up to 2 maximum, not beyond 2. So you need to block that at 2. So in continuity when you will be working, these all the bars will be there adjoining to each other. No gap anywhere you will be finding in between those bars. So in case of bar graph, we were putting a gap. There will be no gap. But all the times this is not going to happen. Suppose your data is going to start with 30 to 40 and 40 to 50 and 50 to 60. In such cases, what we are doing is, we definitely will start in the same manner. You need to draw the y-axis. This sign we will be following over there. Please take care of this. This is called kink, K-I-N-K. What is this called? Kink, K-I-N-K. You need to put a kink over there. Write the y-axis, x-axis and 0 there. Now from here you can start directly with 30 to 40, 40 to 50, 50 to 60 and so on. What does this denote? Kink. I said kink, K-I-N-K. What does this denote? From 0 to 30, whatever the scale you are taking in next intervals was taken up to this also. So sometimes the data is going to start with 150. So I just cannot start like 0 to 10, 10 to 20, 20 to 30 and then at 150 somewhere I will start drawing the histogram. No, then you have to show this kink and start directly with 150 to 160 or 150 to 200. So this sign is enough to indicate that the data we have begun onwards 0 is 150 to 200, means size I am keeping the same, that is what 150 to 200 means 50. 1 centimeter is equal to 50. The gap between that is of 1 centimeter. The graph, square grid paper, the graph what we are using in mathematics is called square grid paper, and you always remember if you will be measuring the length of that square, you will always be getting is equal to 1. So 1 centimeter, that's why you are writing the scale. So along x-axis, your 1 centimeter here, as I said, this is the number of students there. Along y-axis, marks. So 10 marks, 1 centimeter denotes 10 marks. Here 1 centimeter denotes 1 student, 1 centimeter is 1 student, 1 centimeter is 10 marks. So that is the scale calibration. So in that way, here also you can see the gap between this and this is of 10 only. 40 minus 30, 50 minus 40, 60 minus 50, 70 minus 60. That is again 10. So in that way, you need to take care of all these things. But the main thing I added here to your knowledge is kink. What does it denote? Means that whatever the size I am talking in these readings, same was considered onwards to do this. Throughout the scale, we are working within a gap of 10. So it is there, and then the class intervals I shared, like these groups are called the class intervals. Class size also you take care. Once your data is lying in continuous form, 30 to 40, 40 to 50, 50 to 60, so you can say upper limit minus lower limit. Upper limit minus lower limit is the class size. Please make this definition very clear. This is called the class size. So lower limit is this, upper limit is this. 30 is the lower limit, 40 is the upper limit. Another term you need, that is the class mark. So class mark is what? Mean of these two limits. Lower limit plus upper limit. Lower limit plus upper limit and divided by 2. Divided by 2. So suppose you need to find the class mark of 30 to 40. So that will be equal to 30 plus 40 upon 2, 70 upon 2. The class mark of the class interval 30 to 40 will be equal to 35. So that is, whenever you are going to calculate the class mark, you need to find the mean of these two limits, lower limit plus upper limit. Lower limit plus upper limit divided by 2 will give you the class mark. And class size, but remember, class size, whenever you are writing upper limit minus lower limit, there is a condition, the data should be continuous. Whatever is the upper limit of the first class interval, that should be the lower limit of the second class interval, and so on. Then you can use this. So please make a note of all these instructions, and how to draw the histogram, how to calibrate the scale. Then at one of the corner you need to write the scale. You have taken a long x-axis, that you have to mention there, a long x-axis, as well as a long y-axis also. At the top you have to write, and then you have to proceed, and then we will be taking the exercise 5.1 in tomorrow's lecture. I will be definitely giving you the solution of all those 6 questions. Most of the questions are the reading parts, but in 1 or 2 questions he is asking to draw the histogram also. So I will be sharing that with you through the another video lecture, how to draw and how to find the solution of all those 6 questions. Till then, bye bye. Have a nice time. Thank you.